Great. Thank you very much. Welcome to that episode of High Point. I'm changing a little bit the format where it's a bit less formal and less edited, but hopefully we can have some chats, and also to change the topic a little bit about this series. It was more on music, theatres and instruments before, and it will still carry on. But I want to also do a series on timber constructions and sustainability in the construction industry, and which you are a specialist. So first of all, can I ask you to introduce yourself and the company you work for, who you founded?
Hi. My name is Lauri Tuulberg, so I'm mostly occupied with Velement, where I'm a CEO. Founded Velement 8 years ago. And we built the factory from scratch, basically. So it's automated prefab, timber prefab factory. And mostly we ship our products, or sort of we do projects in Scandinavia and now also Germany. But yeah, I would say Northern Europe is our focus, and also Estonia. Estonia is a bit peculiar in the sense that there are a lot of timber prefab companies, but most of Estonia is the biggest exporter of timber prefab houses because it's a small country, so 1.3 million people. And but all around us there are Scandinavian countries, Sweden, Norway, Finland, that is like 20 million people, and then also you have Germany, northern Germany, and so there's a high demand for it. These sort of prefab products, whether it's modular or panelized. And what was lacking when we started Velement was that nobody had an automated setup. So nobody was using robots. It was mostly sort of in these old used buildings, not a dedicated factory setup. And we sort of decided to invest in it. But what made it also possible is that we're part of a construction group, sort of Rand and Tuulberg group, which is basically started by my father and his partner 30 years ago. So it's relatively long in Estonian terms, but you have to bear in mind that the Estonian re-independence was also about 30 years ago.
Mm-hmm.
The group, which I'm also sort of not fully, I'm part of a board of the advisory board for the construction company, sort of helping them with maybe a vision and marketing aspects, but mostly day to day I'm dealing with Velement and prefabrication.
Yeah, I was going to say, I've got lots of questions to ask you about Velement, but also timber markets in Europe and Estonia. I've been involved in an Estonia project, which is the same. We work together on it for pattern buildings, which is a great idea of putting modules together, and it's run by René Poussep. But I've got loads of questions about to ask you. How's the approach in the Nordics countries, and whether you just export also to the Scandinavian countries, or there's more happening in on your side of the Baltics, and generally what's the what you're pushing, particularly what's going on. So how big is Velement? You mentioned about that factory. I actually didn't know, but what sort of technologies do you use, and what do you produce?
So Velement is panelized prefab company, so we don't do fully volumetric units. So I would say, I don't know how sort of what's the audience here, but there are sort of your panelized, so 2D elements, and then 3D volumetric units, so whole rooms that are finished in factory settings. So Velement is focused on panelized systems, and we have Beinmann lines from Germany. So there are robots that are, have a cutting station that is cutting the pieces, the timber studs that go into the elements, and then you have these multifunction bridges that do nailing, cutting, and all sorts of sort of repetitive work, and also with a more higher precision than you would achieve with manual labor. And the point with this sort of setup is, of course, productivity, but productivity comes from your whole factory setup. So it's not, you buy expensive robots and click, you are a productive company. You're not, because that comes from all sorts of small little things that need to work in cohesion and synchronicity, I would say. But it does sort of, these robots are safer, and they are more precise. They are, they don't have any bad days or feelings. So, I mean, it's sort of, that's the point of automation. And in this, at least in this sort of setup, that you take away more dangerous and repetitive work, and you allow automation to do this, and you achieve a much higher precision in a constant, day-to-day operation. So yeah, that's why we opted for it. And you mentioned also these markets. So why Scandinavia, right? So I would say that Sweden and Norway are very used to using timber, and they are very used to prefabrication. So probably Sweden is the most developed nation in terms of prefabrication. Norway as well. And what also is, of course, important is that their time is really expensive. So the time, what I mean is the time working on site. So
yes, I've experienced it.
Yeah, that's why it makes sense to sort of make as much of the value of construction or the structure of a house in a factory setting, a controlled factory setting. It doesn't necessarily need to be in Estonia. It can be also, there are huge factories in Sweden as well. But yeah, I mean, I would say that Estonian factories are more used to doing these one-off projects, so they are more flexible, and they are also used to adding more value in the factory setting, because you need to understand that when the factory manufactures a house in Estonia and they deliver this to, let's say, northern Norway, then you need to be quite sure that everything is in the correct sort of sequence as designed, and all the necessary sort of loose materials are on the truck, because if something's missing, it's quite costly. So if you think about a factory, for instance, in Germany that caters for the local area, then they're probably more relaxed in this way. They don't need to maybe pre-plan that much, because you can always go and fix some of the stuff.
Okay.
So
how did you start Velement, and how did you start the factories? Because it requires some investment or from cash to build a factory with all those robots. How did you start it?
Yeah, I mean, it was only possible because we're part of Rand & Tuulberg Group. So Rand & Tuulberg is sort of, I would say, like a whole value chain construction group. We have real estate development, we have design, sort of structural design company, and then we have the main businesses, main contracting, in infrastructure projects as well, large scale projects in Estonia, hospitals and so on, but also our own developments, residential. And then we have also a manufacturing branch. So we have a concrete panel factory, which is quite maybe the most common way to think about prefabrication in Estonia, and also Finland, for instance, a lot of precast concrete, where the roots go back into the Soviet time, where there was a huge building boom in 1950s and there onwards. And but the Velement side was that we were used to investing in automated or high tech factories, and then it was sort of we saw that nobody was doing this in Estonia, and then we the group sort of decided that going into timber and prefabrication would be sort of logical sense in terms of sustainability as well.
Okay. And you've been running Velement for 8 years.
Yeah, by background, I used to be a civil engineer. By education, I've studied civil engineering and also industrial engineering. And so I used to work as a site manager and a project manager in concrete. So I've sort of gone through the whole ladder in construction. And then I ended up, sort of combining the two degrees that I have, industrial engineering and civil engineering. So now I'm dealing with manufacturing houses.
Amazing. How big is Velement? I'm trying to look on the
It's
page, the
about,
number of employees, and
let's say about 5 million euros turnover is, well, it fluctuates. This year is a bit difficult, of course, but that's for everybody. Because what's happening in the Scandinavian markets, mostly affected by interest rates. But
how many factories? Is that just one, or there's more
Sorry,
than one factory? How many
with Velement?
factories?
Yeah, one.
Yeah.
Yeah, one set up in Tartu.
And how about Han and Tuulberg? How big is it? Just having a look.
It's about like 100 million turnover.
Okay, much bigger.
It's big. Yeah, the concrete panel factory is doing about, let's say, 12 to 15, I think. But yeah, I mean, as I said, our main business is main contracting, which is a high turnover business anyways, and also real estate development. So, a lot of different components.
I've got one question I'll ask because I've got quite a few people lined up for this series from different backgrounds, different countries, and different specialties. But it seems like the panels, like panelized elements like CLT, all the mass timber elements, full of timber, are really expensive, and there's a lot of thought around making different types of panels. I know a few products that don't use as much timber, and sometimes you don't need that strength or load-bearing capacity. I'm not an expert. I'm only a acoustic consultant, but it's quite interesting still. What's your view on the development of those panel products?
Well, I think, if we look at broadly construction for the past, let's say, 5 years is ongoingly going through a transition. So it's changing. It's understanding that it needs to do things differently. There's a huge sort of lack of productivity narrative, which is a bit slow, sort of quieting down at the moment. But there's also the huge sort of mega trend or meta narrative sustainability that is affecting construction. Now, I would say that I think 10 years ago in construction, nobody was really occupied with thinking about sustainability. But they are more and more now, and it's sort of picking up pace. But it was more advanced in Sweden, and I think sort of changing materials or really thinking about what type of materials we're using for making a house in terms of embodied carbon is super important. So timber plays it's one of the solutions to sort of affect the structural load-bearing walls and then the whole structure of it's reasonable to do some stuff in timber, but it also, with these hypes that are happening in construction, it's also, it can be problematic because as you mentioned, CLT, architects have found it very sort of alluring to use CLT in a lot of projects. But we need to sort of remember, what was it meant for in the beginning? I mean, it was meant for maybe doing these mid to high-rise buildings as not high-rise, but let's say mid-rise buildings. And sort of, would it be possible to have a product that would be instead of concrete? So, concrete has a large footprint, and would it be possible to use timber? And I think CLT was a logical step in that sense, that it was strong. It makes the engineering more easier because it's structurally more sort of robust material than frames. But the problem is that you can overuse timber. I mean, I understand that the carbon that it sequesters in CLT panels, but there's no use to using too much of any material. And I think this hype is at the moment, it's reached a peak, and I would say it's slowing down. That it should be used with reason. In some projects, it makes really sense to use CLT. In some projects, it makes sense to use more sort of glulam, whether it's post and beam structure. And in a lot of cases, for the non-load bearing walls, it makes sense to use timber frame elements. And
what's the cost difference? Yeah. Sorry, between.
Well, I'm not really sure. Like, it really depends on the sort of the whole building and what's aimed. But I think I would need to check this. But I would say that it's double the cost. Because and the cost is one thing, but you're just overusing a material. So I would say that what I see in sort of low-rise buildings with CLT, it's more for more expensive houses. So for an affordable house, it makes no sense to use CLT. And so I think that what is it necessary, like in the near future, when the hype fades, this is, where we see mostly CLT used. It's maybe some public buildings. We see at the moment a lot of CLT used in kindergarten, schools in some cases. But I would say that, I think when most of the hype fades, the materials, concrete is not bad, steel is not bad, timber is not good. All of these materials should be used in their best sort of way. Yeah. Because you mentioned sound. So sound is in a lot of cases it makes sense to use some sort of concrete or light concrete or poured gypsum, because you need to have weight and
cavities as well, which at some point you want to control more low frequencies, especially for timber constructions. And obviously you've already lost some space with the thickness of that CLT. And on top of that, you need to add another cavity, so you lose quite a lot of space.
Yeah, because if we're like ultra fundamentalist with using timber, then that can make the whole structure more complicated, more expensive. And as I understand, there have been some research that even with embodied carbon, with large-scale projects, the best solutions are with using the materials sort of in a hybrid way. You use concrete for compression, timber for what's the word? I forgot the English word. Sort of tension.
Yeah.
So, anyways, yeah, using the best abilities of the materials.
Yeah, it's very interesting. And there's the Timber Development UK conference that I attended recently, and I heard I need to find that document. If you know a similar document, let me know. But there's a document that was saying that if how likely the cost of the building would be raised if the team was an expert in timber, especially the architects.
Mm-hmm.
I'm not. I need to find that document too. But yeah, it makes sense now from what you say, and I've worked on projects where it was full of CLT, and the CLT was encapsulated, so we weren't even seeing it, and
because of fire. Yeah, that is super stupid way of using this material, I would say. Okay, you have that aspect that there's sequestered carbon into it, but I mean, to cut down a forest just to use a lot of sequestered timber, and I mean, if you start thinking about it, makes no sense, I would say. It makes sense to use as little as at least amount of material as possible in a smart way, and so on. And yeah,
that's quite interesting. Have you done any studies, or have you seen any studies, costing studies, or that would show the same building made optimized for costs and timber?
I don't have any specific studies, but I can see from, like, I would say that Randa Tuulberg has just finished one, like a sports hall for a school and a community center completely out of timber. We're now building, there's a huge project, like a environmental house in the center of, so the Ministry of Environment will go there, I think, or something like that. So the point is that there's this hype of using timber, but architects can sort of make they were at least like 40% more expensive, 50%. When I talk about this school project, for instance, and in the end, as you mentioned, a lot of that timber is encapsulated with gypsum, just to protect it from fire. And then in the end, you're like, why did we do this? It's more like, let's say it's 50% more expensive. So instead of 2,500 euros per square meter, it's 3,500 per square meter, something like that. I mean, and yeah, I'm not sure that it's sort of a good way of using materials, although they're natural and so on.
I've got questions now, but where do you export? What's the furthest you can export and still be competitive? Furthest country?
The crazy thing that we have exported one small unit into New Zealand.
Okay.
Yeah, it's
Can you export in the UK, in Europe, in Western Europe, France, Spain?
It all comes down to logistics. So whatever you get into a container doesn't really matter. Container transportation is just so optimized, and but when we're talking about elements, or usually with 2D elements, the problem is height, and with 3D elements, the problem is width. So with fully volumetric, the distance from the factory really depends on a lot of aspects, because the width of the room is, let's say it's maximum like 4.2 with the outside measurements. So that really limits your option, and you need to have a higher volume project to justify maybe getting the whole ship to with modules and so on and so forth. There, so the whole logistics thing is sort of its own project, and the height of the elements is so. This is what this is the concept of DFMA, so design for manufacturing assembly, and also logistics would be there. So
actually, I didn't know about that acronym. Well, I've seen it a lot, but I didn't know what that meant.
Well, it means like I've had a lot of architects tell me, like, put these 10 lists, like so for instance, they come into a factory and they say, like, how high elements can you make, or what's the size limitations of your factory manufacturing lines? And my immediate reply is like, that's not really a problem. The problem is the cars, the trucks. So whatever you get into normal sized lorries, you control the logistics, the cost of logistics very well. Whatever you move outside of the parameters of a normal truck, normal being like there are mega trucks and sort of usual regular trailers, so 2.7 and 2.95 meters of height. Whenever you're in that space, you can basically control the logistics quite well, and the cost of logistics. Whenever you move out of it, then you need so the cost of logistics can increase dramatically, whether it's with height or width, when it's out of certain limitations. So design for manufacturing and assembly means that you design something, but I think the better concept is design for X, because there are so many components. It's not just manufacturing, it's just not assembly, but it's also logistics, and it can be also after maintenance after the house is. So you design something into it. You can maybe also put this into circular design aspects, but the idea is sort of you take into account what is good to manufacture, what is an optimized usage of the manufacturing lines, and then also logistics, and then also assembly. Like, how do the assembly workers think, or like what kind of tools they use? So if you're making a joint where you have to, fix a screw in this sort of narrow gap or something like that, that's not designed for assembly because there isn't a tool that you can use for it. Or it can be also simple things where, like, certain screws or fixing systems that are not easily available. Sort of, you need to take all sorts of these aspects into mind, and it's very difficult to put these into these 10 commandments of the DFMA. You really need to understand the concept, and it's not rocket science, not at all. But you sort of need to understand the general sort of limitations if you want to do a cost-efficient sort of structure or a cost-efficient design or architecture. And then if you know these, then it's quite easy, because, if you draw a line, you need to sort of, okay, I make this piece, this is an element, I make these windows such and such height, and then I can optimize the material here. So, yeah.
It's quite interesting, which means it's probably, obviously there's the traditional way of building buildings and designing them, where you design them without the contractor, and obviously you tender it and get a contractor on board. But it seems like it would be so much more effective to have the contractor leading everything, or have at least a timber subcontractor involved as a designer as well, or with designers alongside, and like as early as possible. Obviously, it's really hard to convince the client to say, spend that much money before we even know anything. But say this will be, and it's really hard to prove once the contractor is on board how much money they've been able to save, because there's a better idea on how to optimize things, and it's really hard to know how much we could have saved if we go the traditional way, because it's really hard to come back from it, because there's a lot of time that's needed to rectify things.
Yep.
What's your experience in all this?
Well, we have two types of clients. So the client that we're really looking for is what we're calling like a product mindset client, or product owner, or whatever. But think about it this way, that it doesn't necessarily mean that they are doing catalog houses, but they are thinking in a product mindset. So there's all sorts of aspects of DFMA or whatever. They already know this. They already know how difficult it is to, and they know how important it is to get this knowledge upstream as early as possible. And so we call these product mindset. Then you have project mindset businesses, clients, which is regular construction. I mean, most of the projects are prototypes, and we do it over and over and over. So in best cases, we use some sort of joints or ideas that work, but the architecture is something that, it defines. So in that sense, those projects, as you mentioned, the prefabrication there is, in a lot of cases, it's an afterthought, and which really makes not a project like it's in that case, it's not prefabrication, but it's post-fabrication, because you are sort of making it into elements after the architecture has already been done, and you are all constantly fighting, against the architecture in a way. Not necessarily all the time. I mean, like, but it's really good to sort of work with a product mindset company, because it's just, you get much optimized solutions. And it doesn't necessarily mean that a project business can become a product mindset business, sort of. I don't know. Yeah, well, anyways.
It's interesting to question the approach and see what is not efficient and why we use different things, and do we need to change them and look at what's the alternatives. But yeah, it's definitely not on timber projects. We keep, as consultants and engineers, keep saying you need to add the engineers as early as possible, otherwise you lose money. And it's really hard, and it's not we're not on projects as early as other disciplines like the architects, and I don't want to give all the responsibility to the architects or the project managers, but yeah, it's really hard to convince clients to spend more money, as I said.
I would say, like, for instance, in sound, in the case of sound. So an architect, it's quite easy where let's even leave the logistics aside, but let's just take sound, for instance. And then, so they do a room, let's say 6 meters in the span, and they leave, let's say, 300 millimeters for the whole intermediate ceiling or floor, and then the vibration, and if you, let's say, you specify in the project that you want to use timber, but if you go outside of, let's say, 4 meters and so on, then the sound, the vibration sound, I mean, it's just not possible to do this with let's say regular timber. You opt for then engineered timber like Glulam or RBL. But in a lot of cases, it could be that it's just not possible in that case at all. So you need to go higher and then have this certain layers, as you mentioned, air and then
Mass
weight
as well,
and so on.
stiffness.
Mass.
Yeah. How about so I'll introduce it. in Scotland, there's a lot of research. I don't know where it's at the moment. I'd like to have a guest on the podcast to talk more about it. But I know the strength of the timber is not as great as for other countries in the forest. So CLT and mass timber elements can be produced, but the strength. I'm going to quote again. I'm not an expert in this, so if you want to make any comments, write them, contribute to it. But the timber, the strength of this timber produced in Scotland can only be C16, but we need C24. Is that right? What's the strength of the timber you can produce, and can you add more about the challenges producing?
Yeah, well, me mostly purchase C24 timber. So, and you are right that there are certain regions that probably have problem. I think, if I remember correctly, it was years back, but I think it was the same issue with New Zealand. You have really sort of fast, rapid growing timber that is structurally not so. I mean, I could be mistaken here, but I think it was the same, like C16 or something like that. Or, yeah, I mean, if you look at the forestry map of Europe, then you see that a lot of it is growing in our region, north from here, Finland, and then you have also northern sort of Russia. So, yeah, it makes sense to use the timber that is growing here. And that's also maybe the case where, you know, like why would we buy, like if the timber in, let's say, in Denmark or Scotland is not structurally okay, then the question is like, should you be using timber at all? Or if you need to use timber from Finland, for instance, or before the war from Russia, does it make sense to export or import the timber as a raw material, as a sawn sort of structurally already as a structural timber? Or would it make sense to add value to it in Estonia or Finland, where you already, because like the house itself is, or anyways, a multi-component product. It's not just timber. It's not just gypsum. It's a myriad of materials: steel, plastics, cement, and whatever. So not just timber, but most of the materials probably are not coming from Scotland. They're coming from something. Windows are made in Poland or whatever. Gypsum is made in Hungary. I don't know exactly where, or Germany, whatever. And so it all is a huge network of logistics and then supply chains. So it's just, the question is like, where does it make sense to add value to it? And so I think, it's because the whole aspect of regionality, which is part of the circular mindset, you control, you buy locally, but it's not just possible to do this in construction. I think we are sort of connected by ultra sort of global supply chains.
What are the limitations of having timber that's only C16? What sort of, can you still build buildings with
I would imagine it's just a question. I mean, I'm not really a structural engineer, so
okay.
I did study civil engineering. I'm sort of more from the management aspect, but I would say the question only boils down to like, what are your calculation systems? I mean, you can probably use C16 as well, but you just need to calibrate your whole structure. And just usually, again, like this is what is usually used in Estonia. And if you can also think about this as like if you design something that is usually available in the supply chain, you control the cost much better. And it also goes for instance, glulam. I remember a project where the art designer put into the beam, or some, I think it was some sort of beam that was with the strength of GL 32H or something like that. And it was basically like just one company that could do this in a certified way, whereas the architect could have gone to a lower grade uh, sort of beam, glulam beam, and it would have been much more easily available. So it's just, I would say, what type of, if it's a one-story house, you can probably design this structurally quite well, but but for instance, in our climate, if we're sending houses to Norway and then Iceland as well, which are earthquake prone, and you have the load of snow in Estonia, which can be quite high. So, I
I
haven't heard.
I went to Latvia last year, and it was around January, February, when it was for work. And then it was -8, and it was really cold, and I needed like thermal clothes. And I said, "Oh, it's really cold." I said, "No, it's okay today. It's when -25."
Yeah, it can be here as well. I mean, it's not in the past winter. So, well, actually, last winter was also like more constantly cold. So in this case, for instance, in this year in Estonia, it's been a abnormally warm autumn. There's no snow. It's 10 degrees plus. Usually by this time it's -1, -2. It's already snowing. So it's very, maybe it is climate warming effects, but it's, I mean, it's quite dramatic.
Yeah. I've just spoken about Latvia, and I know, so there's a small uni called DFMA uni, where it's very forward thinking, trying to teach in a different way, but also very modern topics of construction. How is it in Estonia, and how do you see education going, the situation as well? Do we need more, like, to update all our principles, maybe not, or teach like new topics, or we learn everything on the on site once we're qualified, and just learn all the basics? What's your view?
Yeah, I remember when I started civil engineering, I think the problem, and it's not, the people who are, the problem in Estonia, I would say, is that there are not a lot of young tutors or university professors. And there's a demand for them, but nobody really, not a lot of people want to go into this field because there's a little money into it, in it. And then, so the problem is that you have an older generation of professors that who were educated maybe in the, I don't know, 50s, 60s, 70s, and then they are teaching to people who are now growing up, like, let's say they're now coming 18 years old, or my son is 12 years old in January, and in 6 years is, imagine the world in 6 years at the moment, what is happening. And then in terms of, what will probably happen in sort of, like how we do structural calculations, how we, construction norms, like I'm not saying that it will be like, we don't need any engineers. We definitely need engineers. We definitely need architects, but it will just change the way we, how we sort of approach design, or like what types of tools we use. And I think that also goes for education, that there's this divide because the rapid change what is happening at the moment, like how I see my son approaching computers and tablets, and then so it's just, I think this gap is a bit, I'm not saying there's anything wrong with older professors. We need experience, we need sort of smart people, and then the age doesn't necessarily mean that somebody is sort of an old timer or whatever the word would be here. But I think that we, whatever we do in terms of education, we just need to incorporate into the model change. So everything changes all the time, and it needs to be a normality. And with the speed of change that is probably happening, nobody really knows where there's a lot of hype, there's a lot of sort of bullshit as well. And so, yeah.
I agree. I mean, I can't not agree. Because that's what we're trying to do, with DFMA, is to, while still teaching the same thing, maybe you need to be taught in a different way, like online courses. That's what we're trying to do at the moment. But it's bloody hard to create a full course, and we're still, I'm still learning how, I'm still adding things to it. But I'd always remember when I was at uni, there were some topics that I was really struggling to make sense of them, and I was really struggling to focus. It's just my personality, and also I had to reread everything. And you have to sit down, and you have to sit down for an hour. You can't take a break, and there's loads of techniques for work, and there's one that I like using, is called Pomodoro. So you do 25 minutes of working, and then you do 5 minutes of break, and then another 25 minutes of working, and that doesn't fit very well in the an hour module setting.
Mm-hmm.
And obviously in terms of logistics, really. So basically there's different ways of learning for everybody, and maybe the unis need to make more effort, or need to think more about how it's done. And then also, obviously, we've got kids. I've got younger kids, but we're already like very aware of how our kids are with learning, what their passions are, and you wonder whether the traditional way of getting diplomas and getting educated is right for them, and whether there's alternatives. I was talking recently to a person who's homeschooling, so that she doesn't do all the courses for her kids, but they share the courses and they teach things. And they also learn real life things like cooking, how to manage money and stuff like that, which is so important.
Absolutely.
And I've always thought, homeschooling, I don't want my kids to be out of the society. And it's what my narrow-minded Mark was thinking. But actually, maybe homeschooling is one solution, or a hybrid way of doing it. I've got another guy, a structural engineer, who's taking his family around the world on sailing, and he just does homeschooling. But it couldn't be, homeschooling can mean online courses done by unis, and then you take quiz or diplomas or stuff like this online, and then at your own time. And it's and as we say with the timber industry, there's so much more we need to know on not just the basics, but sorry, it's a long monologue.
No. It's
there's things. I think if things need to be shaken constantly, it's not just us. Our generation, our kids' generation will shake us as well as we'll get old. It's just things evolving and things change, and we forget that there's origins for everything. Origins were created for certain situations which are redundant now.
it is. I mean, for instance, I think the Estonian education system is changing quite well, because I was born in 1984, so I went to school started my school in 1990, and you need to understand that it came from the Soviet system, so it was not a lot of free thinking. you can just imagine. But you know how our parents were, my parents were taught, and you know they actually had to learn like this Leninist stuff, and then you know like it's like crazy to think what types of world you know they have seen, or like for instance my grandmother who is still alive and then 95 years old, so has seen all of these, the first Republic of Estonia, and then the Soviet occupation, and then now the new republic. But so this is all changing. I think and you know, as I said, I studied also industrial engineering. So I studied industrial engineering in Hong Kong, University of Hong Kong, and then that was a very British system. So I taught masters where less courses. So the education, civil engineering in Estonia is more like very rigid, very not rigid is maybe not the right word here, but it's sort of
Structured.
yeah, very structured, very sort of like you just put a lot of materials into this heads, and then you just like chemistry, technical mechanics, algebra, like all sorts of stuff. You just physics 1, physics 2, and everything is sort of standard. And then I spent like 1 year in Hong Kong, well, like the whole course in Hong Kong, and then that was all completely different. You had less courses, you had one goal at the end of the course, and then you have a lot of sort of also individual studying. Sort of you need to sort of find a way, and I'm not necessarily saying that the Hong Kong way of like the British sort of tutoring way is better or worse. I think they all need to change, and I think what it just taught me like more independent learning, more independent, and I think the what they should focus on is like how to think, and not necessarily what to think. Is like, and maybe sort of what types of tools to use to reach this sort of solutions. Is yeah.
Yeah. I mean, we're about the same age, so
yeah,
about the same generation. Before asking you where you think the whole industry, timber industry, I've got 2 questions. You spoke about Han and Tuulberg having different productions or producing different products. What's your insight or view on the materials that are more sustainable, like alternative materials to masonry-based materials, or maybe like sustainable masonry? But we see, for example, a lot of hempcrete as a replacement to like concrete blocks, and obviously there's other challenges to sustainable materials. They're not all perfect. They're quite expensive. There's probably less resistance generally. I say that from an acoustic view. Yeah.
No, I think this is what I've been occupied for the past year. Basically, it's like the focus on sustainable materials, not just timber is sustainable, but what I mean, like up to maybe 2-3 years ago, I think the main focus was or had been operational carbon. So the energy we use in the buildings that we build. So, and now most of buildings in Estonia are near zero emissions buildings. So you need to have an A class. It's probably all around Europe. So I think we got this covered. The operational carbon for new builds is not a problem anymore. Now the question with operational carbon is just how much we can improve the existing building stock. Because, for instance, even the last project that I did as a project manager, the what is that in English? So the air pressure, the pressure, air pressure number. So forgot the word. Anyways,
Pascals.
Like, yeah, it's 6. Like it was 6, but with the near emissions buildings, like what we see at the moment, what we achieve is 0.5. The air leakage.
Okay.
Anyways, you mean
Sorry,
you know what I mean. But So anyways, I think we have this covered with operational carbon. What we now are seeing is a huge broad topic is like, the CO2 footprint of construction is huge. It's the it's 40% of the global CO2 comes from the built environment, which is like, if you start to think about it, what the hell does that mean, built environment? And that means actually also operational carbon. It means the whole building stock that we have and the energy that we are using. But okay, so half of it, let's say roughly, actually it's 2/3 is operational carbon, and then you have embodied carbon, which is like 11%. But most of that comes from materials. And most of that comes from cement, steel, aluminium, logistics. And then you have like the rest, basically. So 90% is, let's say, these 4 or 5 materials. And we're talking about cement, not concrete, right? So cement, there's only a portion of cement goes into a concrete mixture. So, but I think what will be really super important in the next 5-10 years is how we look at the whole embodied aspect. So, of course, the focus, 85% of the problem is in the manufacturing of materials that we use in construction. But my whole point here is that, but that's the manufacturing sector. Because, Velement is a manufacturer. I'm not a construction company. So I know it seems like, why are you talking about this? But the point is, like, I define myself as an offsite construction company because I build a house in a factory setting. So I'm actually a construction company. But statistically speaking, I'm a manufacturing company. Statistically speaking, a window manufacturer is also a manufacturing company, right? But my whole point here is that the construction sector, most of the footprint comes from the manufacturing. But when we're, like, most of the productivity also is in the manufacturing part of the construction, because the whole aim is to move as much as possible from the work to the factory setting. But so we need to sort of understand what we really are talking about when we're talking about footprint of materials, and then where does it happen. But I think it's improving because one thing is that all manufacturers in Europe are becoming greener. The whole grid is getting greener. We can be pretty sure about that. So it's becoming greener. It's becoming electrified. So whatever materials we're using, they will become greener, and also that means green cement. And I think we'll sort of reach some kind of normality here. But I think sort of that is what is super important. And but for instance, at the moment in Estonia, there's a huge debate where, and after our podcast, I will have a meeting with a couple of people and then one person from the ministry as well, is that the timber number in the footprint table is almost the same as concrete. And the whole idea is that we are sort of perplexed by this. Is like, what the hell is this? How can timber have the same number as? Well, because in the LCA calculations, we are taking as an assumption that the building will be demolished in 50 years. And the wood will be burnt, and the CO2 that was sequestered in the timber will go back into the atmosphere. Which is, like, it's idiotic, because 97% of the buildings will not be demolished in 50 years. So my point here is, just stop me when I'm ranting too much here. It's just, my point here is...
I'll let you speak.
Yeah, but the point here is just to... I want to talk about is, like, what is important at the moment. So the importance at the moment is to lower the footprint of lower the CO2 numbers as much as possible. So because the Paris Agreement, we say that, we need to keep it below 1.5 1.5 degrees. Right. If you look at it, then what does it mean 1.5 degrees? We've actually already did the 1.1 degrees, so it's only 0.4 degrees left that we can raise the global medium temperature. And that's for the next, let's say 70, 80, 100 years. So the deadline is 2100. So that means that whatever we do right now with the materials is super important. So it doesn't matter, in my sense, that if we, take into LCA calculations that in 50 years the house will be demolished. So it doesn't matter if you're using concrete or timber. So, but we know that there are two houses. One is concrete, one is timber. The one with concrete built right now will be probably twice as much CO2 than the house built in timber, because it will be sequestered for the frost. So if we say that this whole narrative of global warming and 1.5 degrees or 2 degrees for the next 50 years, and Europe wants to become net, so carbon neutral continent by 2050, right? So that's 35. It's quite, little time left. So whatever we do right now is super important. So I think I have huge questions with these LCA calculations and the whole cradle to grave. Forget about the goddamn grave. I know it's important in the circularity mindset, but I mean, what it's important right now is the cradle part, is like what types of material we're using to achieve a sort of target where we're using as little of the CO2 as possible. So we emit as little of the CO2 as possible right now. If we're saying that this narrative is not so important, then okay, let's just then think about the grave part. But we are not demolishing the buildings. We are refurbishing them. We are renovating them. We are repurposing them. And in some cases, yes, maybe they are demolished. But if that CO2 is already put into the product, then the stupidest thing would be design a demolishing aspect into it, I think. It's almost like propagating fast fashion. It's like, in my sense,
Interesting. Obviously, podcasts are made to let the guests speak and have their view.
Yeah, I mean, of course, it's my view, and I know I sound emotional because it's just something that I've been dealing with the past months, and as I said, I'm part of a small sort of work group that will give some advice in the coming weeks in terms of how we approach these materials, because we need to say what's on our mind from the practitioners, because otherwise academics or people from the academics, consultants, architects, or like people who don't know what stuff costs or what stuff really like downstream knowledge from the construction. Because the problem with civil engineers and construction people is that they are quiet. They don't care, they have stuff to do, and then architects are much more vocal, and consultants are vocal, politicians are vocal, but they don't know construction the way we know construction. And then suddenly you get a norm or a policy, and then the tender documents, and you need to take these types of circularity aspects and the blah, 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 blah. And then, for instance, what comes out is that timber and concrete have the same CO2 footprint. So, I mean, we need to just, speak our mind, the practitioners, the civil engineers. If something is stupid, then just say it and call out, criticize it, because otherwise it comes policy, and later on it's much more complicated to change this.
I think every discipline, every engineers or every consulting discipline should be providing a bit of quantity surveying, so costing services as well for their own part. Obviously, there's a when I started acoustics, and in the companies I was working on, people used to say, just put give a spec, and we don't look at pricing of solution, we look at the performance of the solution.
Mm-hmm.
But it's a little bit redundant because there's so many ways to achieve a certain performance, and you need to be more aware of the costs of your design.
Mm-hmm.
And for very specialist buildings, like timber buildings and also performing arts projects, you need to have an awareness of the cost of things. And you need to, if you don't, you need to be able to look for it yourself and understand it, because and it makes you a better engineer and is more valuable as well. So I'm really like, from there to say, we'll just provide some some pricing, some cost of what we do. Obviously, it needs to come with an expertise, so we need to create that expertise of costing. But yeah, it's some basic stuff. I'm not saying very difficult construction should be costed by non-experts, but at least some basic quantities.
Should be. I agree totally that it doesn't need to be super accurate, but in the early stages of design, if those sorts of just a little bit of just be some very simple things that affect the cost, and in the early stages of design, if this knowledge, it can be cost, but also like the CO2 aspect, if this sort of material choices or like material properties are taken into account in the early stages, it can like you can control 80% of the cost in the early stages. But usually if you have the construction permit and the contractors already start doing it, you can just, fine tune the costs. You can't really revolutionize anything. Or you need to just go back and redesign something, which is just stupid.
A few last questions. Where do you think the construction industry is going, or timber industry is going, or should be going?
Yeah.
It could be in terms of products, materials, regulations, guidances, education.
I think, one should follow the trend. So I think the trend of sustainability, which is this whole meta-narrative, it's not going anywhere. This will become, and all sorts of choices, like material choices, will become super important in the coming 5 years. I think construction at this stage, or at least in the past 5 years, it has been very sort of, innovation from the other industries or startup industries has just sort of like jumped into construction, and prop tech and real tech and contech, have these very cool words now. And then you have sort of, and I know I'm critical here, but sort of really dumb ideas like printing houses or like masonry robots or whatever. And I mean,
what do you think is not a solution?
Well, we can fill the whole show with this. It's not a solution, because if something can be automated, it doesn't necessarily mean that it should be automated. First of all, you start with the basics. So you're printing a cement-based one-story house. It's cement-based. You have that's already, in terms of sustainability, it's moving the other direction. But okay, fine. Let's say they figure out another material and it will be green cement or whatever. But you can only do the supporting walls, and the structure of the house is a multi-component. I mean, you can affect, like, the whole idea would be like, why would you do it? Okay, we can cut down the costs, but you can't really. I mean, like, it will be a really what people get really wrong with using machinery and robots is that they're cheaper. I mean, machines cost a lot of money, and maintenance costs a lot of money, and handling the machines and giving commands to the machines they require a unique skill set that costs money. It's not free. So there are these, snippets from the manufacturing industry. Yeah, but it needs to scale and economies of scale and you and then the whole concept of scalability, which comes from the manufacturing, like the startup. But yeah, but the IT sector, I can understand what means scalability. You have an hockey stick, you figure out a code and then you manage bandwidth basically. But when it comes to the printing of a house, it's you can achieve sort of linear gains, but you still need the operators there. So I'm 95% sure that it's more costly, and I'm 95% sure that this scalability will be nothing to this. And at the end of the day, I'm 95% sure that it doesn't affect the cost, because from the whole building is, like, you have windows, tapes, insulation, whatever, cables,
Mhm.
it's super complicated. It's the same thing when I told you that, let's start printing cars and it will make the cars super cheap. But probably it's very easy to understand that you can't really start printing cars. You figure out, okay, maybe the frame, but you completely understand that your BMW is not your frame. It's the super complex organism and the IT system that's surround you as you move in the space. So, I mean, it's just somebody has to be critical. I've been vocal about this for a number of times. And also, like, let's say even masonry units. The masonry unit is a building block that's made for a human hand. So let the brick, for instance, it's made, that's why it weighs that much. And then if you can make a robot that can lift a ton, why would you make it just then already think completely out of the box? Um, I don't know. I mean, it's just very sort of, these academia. It's possible, it's interesting to study sort of this because everything has been studied. So maybe it's boring. So let's try to make a robot that prints a unique shape or whatever. Um, yeah. But let's see. At the end of the day, I can see some applications in a factory setting. So in control factory setting, you control the moisture, you control the temperature, because concrete is quite, problematic material when it comes to temperature and outside sort of environment. Um, Maybe, yeah. You have this Chinese printing factory that's doing this in the factory setting. But at the end of the day, it's a niche thing. It's a hype, and it will burst. Bubble will, 2-3 years. Yeah.
Maybe we'd organize another episode in 10
Yeah,
years,
sure. I mean,
and see. I'm not challenging you, but it
if
would be
somebody can
interesting.
just
I'm
explain
not.
to me
Yeah.
the explain why I'm wrong, and I'm 100% willing to listen, and I'll start a printing company right away if you can explain to me. But even with our machines, you know how difficult it was to get the
Mm.
machines working in an ultra precise way. And okay, they will become smarter and so on and so forth. But at the end of the day, it's just, it's like the CLT aspect. It's, why would you do a one-story building out of cement when you can just do it more easily, more robustly with, let's say, timber frame or whatever? And then you still need to do loads of other stuff with when you're doing the printing of the walls. And then, I mean, it's just, I don't know.
Yeah.
Yeah.
I see where you're going, and I agree in some ways that 3D printing houses is just a very small bit of a bigger process, and it's a bit like AI, which to me is obviously there's still the hype around AI, and it's great. I'm using a load of tools with AI, including with Riverside, with this podcast. But we thought, as part of the hype, that AI would be able to do so much more than it can actually do. We can still use it a lot to optimize processes like 3D printing. And it's nice, it's fancy thinking about it. But there's loads of small processes, and instead of thinking of that fancy process, maybe let's think about automation. And it's a bit more boring. Sometimes it's optimizing what you're actually doing.
Yeah, I think, just when we talk just briefly, maybe some aspect of the future of construction that, let's say, that makes sense. I mean, like, I would say the whole aspect, sort of this generative design, I think this is really super interesting. And, this leads to a field that, like, okay, maybe we don't need architects anymore. I think we definitely need architects. But I think what it will achieve is, like, you're allowed to, like, for instance, how I use everyday ChatGPT. And I think it's becoming stupider now. Like, maybe I'm getting better at it or whatever, but I think, like, it's just your assistant. And the work because I work with text a lot, and, like, something that used to take me 3 hours now takes me 20 minutes. And it's not like I'm doing lots of productive things with the 2 hours, because I think humans, when they figure, like, we are lazy, so we invent robots so that we can just, to spend time with our family, maybe, do some sports, maybe think about, I don't know, some mental activity or whatever. I mean, read. But I think we can interpolate from here that what will be the most likely usage of this in engineering, and it will be probably design. It will allow the architect also to, like, speed up the searching aspect of architecture, because, like, when you design a house, there's always this searching part that the client is not willing to pay for, I would say. Like, because out of the 10 hours that you are designing a house, probably maybe 9 you are searching for the right answer. You're letting the design solution come to you. You're almost like discovering the design, right? So, and I think that discovery aspect is something that doesn't make the architecture more cheaper. It just allows maybe for the architect to work more on the more enjoyable aspects of finding the right solution. So it's just these mundane, repetitive stuff that will be more, like, prone for automation.
It's a good last word. Thank you for attending that, accepting the invitation. It's been really interesting, and I hope loads of people will listen to this.
Yeah, thanks for inviting. It's always good to sort of discuss and restructure some thoughts.
Yeah. No, your approach from where you are is interesting. And I'm sure there's been a lot of really, again, rich and interesting things you said or insight. So yeah, thank you very much. And maybe have you in another episode about something else. But yeah.
Sure.
Cheers, Lauri.
Cheers.